So let's go into simultaneous equation. Right. Okay. So if you consider the third question, okay, the third question you can see a set of simultaneous equations which you are like really familiar with, right? Would have done questions like this in your O levels. So let's first of all go into those types of questions, and then we'll come back to the first question, okay, first and second question, where you have to follow a slightly different method, okay, so just a different technique, that's all. So first of all we'll deal with the third and fourth equation, fourth questions. So yeah, so when it comes to solving simultaneous equations, what you mainly do is you try to eliminate a certain term, right? You somehow try to eliminate a certain term from the equation, and you try to get a simplified equation which contains only one unknown expression or one unknown term, right? So you have t1 and t2, so you can attempt to either remove t1 or t2 from these two equations and get an equation where you have only one of these. So for that, what you have to do is you have to uh, you have to take these two equations. I have two equations here, and we'll mark them as the first equation and the second equation, number one and number two. So what you can do is you can do some sort of arithmetic operations like adding, or you can subtract, okay, or you can multiply something. So by doing some sort of arithmetic, okay, by doing something, you can cancel off a certain term from these two equations. So here you can see I have a plus t2 here and I have a minus t2 here. So you can see if you have a plus t2 and a minus t2, or just for example, if you have a positive value like plus 5 and you have a negative value minus 5, if you add these two, like plus 5 and minus 5, you'll be able to get 0. Okay, if you add plus 5 and minus 5, you get 0. When you add 5 and subtract 5, obviously it becomes 0, right? So if you have plus 5 and then minus 5, and if you subtract them, okay, if you have plus 5 and minus 5, you subtract these two, so plus 5 minus minus 5, okay, so 5 minus minus, you have a minus here and you have a minus here, so they get multiplied and they become plus. So 5 plus 5 becomes 10, right? So this gets you a certain value. If you subtract these two, if you add these two, you get 0. So here, when you consider these two equations, and we have plus t2 and minus t2, we can add these two, right? We can add these two equations uh, to get, like not to get, but to remove t2 and this minus t2. So you can see when you add these two equations, what happens is this t2 and minus t2, they get cancelled off, and you are left with t1, and it gets added with 2t1. You get 3t1. Okay, you have t1 and 2t1, those two terms get added, you get 3t1 plus t2 and minus t2, they get added, they get cancelled off. So you have completed the work in the left hand side. You can move to the right hand side. In the right hand side you have 100 and you have 20. You can add these two, so 120, when you add these two you get 120. So now we have a simple equation 3t1 equals 120. So we can divide both sides by 3. We are left with t1 equals 120 by 3, which is 40, right? So t1 equals to 40. So let's substitute 40 into this. Now what you can do is you can take one of these two equations and you can substitute the value we got, and you can find the value for the other unknown. So for example, substitute in the equation 1. So we have t1 equals 40. I put it in the first equation. So 40 plus t2 equals 100. So t2 equals to, okay. So here you can see instead of t1 I have put 40. Right? T1 is 40 now. So 40 plus t2 equals to 100. So I take 40 to the other side. So it gets subtracted from 100. So 100 minus 40 is 60. So t2 equals to 60. So we have the two values 40 and 60. Right. So that's how we deal with simple simultaneous equations. So let's get to the next one. The next one, if you consider now this equation, like you can't just directly get, you can't just directly eliminate something by doing what we did in the earlier question, right? We can't do that. We'll have to follow um, something similar to this, but we have an extra step to do. So let's see what we can do. So now you have f1 plus f2 equals 50, and then you have 3f1 minus 2f2 equals 0. So when you have two equations like this, uh, you can see now when you add these equations, right? When you add these equations directly or when you subtract these equations directly, you can't eliminate an expression. You can't eliminate a term, right? You have f2, you add it with minus 2f2, it doesn't get cancelled off. You have f1, you add it with 3f1, doesn't cancel. You subtract these terms and see, but still it doesn't get eliminated. So what you have to do is, right? So what you have to do is you'll have to do some alterations to this. So this is the first equation, this is the second equation. So what you can do is you can take one of these equations, let's say the first equation, it looks a little simpler. So think about it. Like if you have 2f2 here, like if the term was 2f2, then you can easily add it with the second equation and they'll cancel off, right? 2f2 and negative 2f2, they'll cancel off each other. So for that, what you do is you multiply the entire second equation, first equation by 2, right? This is the previous one. So you multiply the entire first equation by 2, right? So what happens is you have 2 times the entire first equation f1 plus f2, and you have to multiply the other side also by 2. So 2f1 plus 2f2 equals to 100. And then the next one, 3f1 minus 2f2 equals to 0. So that's the second equation. Now I'll name this as the third equation. This is the second equation we already have. So now you can see 2f2 and minus 2f2 can get cancelled off easily. So I just have to add the third and second equation. So 2f1 and 3f1 get added and you'll get 5f1. But 2f2 and negative 2f2 get added, they'll cancel off. So 100 and 0 gets added, you have 100. f1 equals to 100 over 5 is 20. So we found f1. So substitute this value in the first equation. f1 is 20 plus f2 equals to 50. F2 is 50 minus 20, which is right. So you have two values, F1 and F2. F1 is 20, F2 is 30. So now you can do the seventh question. Um, yeah, seventh question, the 11th question using similar concepts. Now let's get back to the first equation we have, first set of equation we have. In that, now we have to follow a certain uh, method, right? Here they have given t sine theta equals to 20, and they've given t cos theta equals to 20 root 3. So they are asking us to find theta. So what we have to do is, now we don't know what is theta and we don't know what is t also. So t and theta both are unknowns. So you can't just directly solve this. So what you have to do is you'll have to remove one of these terms. So what you can do is you can remove t. You can remove the capital T. You have to find theta now. So if you can remove capital T, then you can deal with this equation easily. So what you do is you take the first equation. You first of all name these equations as the first one and second one. Then what you can do is you can divide divide the first equation by the second. Okay, so that is the technique you can use here. So when you divide, what happens is you can see the first equation has t sine theta in that side, and second equation has t cos theta. So that's equal to 20 over 20 root 3. Okay, on the other side we divide 20 by 20 root 3. So you can see t and t would get cancelled off. So I have sine theta over cos theta equals to 20 over 20 root 3. So cancel off 20 and 20. 20 divided by 20 is 1. 20 divided by 20 is 1. So 1 over root 3. Now what is this sine theta over cos theta? This is something important. If you can remember this, it's really good. So what is sine theta over cos theta? Something from trigonometry. Sometimes you would have learned this. So sine theta over cos theta. The answer gets you tan theta. So if you divide sine theta by cos theta for the same angle, the answer you get is tan of that given angle. So sine theta over cos theta is actually tan theta. Tan theta is 1 over root 3 it seems. So you should find out which angle gives you tan theta equals to 1 over root 3. So it is 30 degrees. You know tan 30 is 1 over root 3. So answer is supposed to be 30 degrees for theta. So always divide sine by cos. Right? Next, now you have the second equation, a very similar uh, question. Let's just quickly do it. So first one and second one, we will name this as 1 and 2. So I need sine theta over cos theta now. So I'll just divide, in this case, the second equation by the first equation. I have sine theta in the second equation. So I'll divide the second equation by the first equation. So v sine theta gets divided by v cos theta, and on the Other side we have 4 root 3. Here we have 4. Right? So 4 root 3 over 4. 4 cancels. V cancels. Sin theta or cos theta is, again, should remember it's tan theta. Tan theta equals root 3. Theta, for 60 degrees you get tan 60 as root 3. Right? So theta equals to 60 degrees. Okay. So you can do the sixth question similar to this. Eighth one is similar to this. Ninth one, of course. 10th one, we'll do this. Okay, we'll do this now. So 10th one, it's also just like simultaneous equation. That means just like the ones we solved earlier. But you can see here we already have a direct relationship between V1 and V2. So what we can do is, instead of trying to solve it in other ways, I can just insert 0.2 V2 into this equation. How am I going to do that? So V1 equals to 0.2 V2 now. So instead of V1, I can use 0.2 V2. So what I do is, instead of V1, I put 0.2 V2 in that place, and I add V2. So I'm left with 24. So 0.2 V2 equals plus V2 equals to 24. So 0.2 V2 and V2, no, it's 0.2 plus 1. It's like that, right? V2 means 1 V2. 0.2 V2 is 0.2. So when you add these two, it's like adding 1 and 0.2. You get 1.2 V2 equals 24. So V2 equals to 24 divided by 1.2. So now you have to divide by a certain decimal number. So dividing and working with decimals is also another important skill that's required. So here I'll just quickly say how we can do this. You have to shift. Now whenever you divide by a certain decimal number, you should make sure that the decimal place is after all the numbers, right? You should take the decimal place or the decimal point behind all the numbers. So it should be shifted to this side. To shift that, you'll have to multiply by 10. If you multiply by 10, the decimal point would just shift one place to the right. If you multiply by 100, by 2 places. If you multiply by 1000, by 3 places. So that happens. If you do it, multiply by 10, uh, you should do that same thing up as well. You should do it for the numerator as well. So you have 240 divided by 1.2 into 10 is 12. 240 divided by 12 is 20. So V2 is 20. And we know V1 is 0.2 V2. So we know what is V2. So 0.2 times V2 is 20. So 20 into 0.2 is 4. Here also, now when it comes to multiplying numbers by decimals, what you have to do is, you just forget about the decimal and just multiply the two whole numbers. So you have 2 and 20, you get 40. What you do is, now you have, in order to, now when we were multiplying it, we just took it as 2 into 20 now. So for that, what did you do? You have taken the decimal point and you have shifted it to the right? And you got 40. So now you have the decimal point here. You should shift it one step to the left. So you get 4.0 or 4. Okay, because the decimal shift has to be taken back. Now you just took it you shifted it to the right, so you'll have to compensate it by shifting it to the left. So 40 equals 4.0 if not 4. So V1 is 4, V2 is 20. So we have some other problems as well. You can give this a try.